Next up, we have Dr. Brian Lee with us. Dr. Brian Lee has been teaching physics and astronomy at Santa Fe College since 2014. He believes the power of the modern classroom is in getting dozens of minds in the same place to construct shared explanations about how our world works. Brian is always on the lookout for better ways to scaffold course activities to help students experience successes at as accurately modeling phenomenon in nature. So Dr. Lee, I'm going to pass it over to you.
All right, thank you very much for having me. So I teach physics and astronomy at Santa Fe College in Gainesville. And today I'm going to tell you about how I used a specific AQ technique that was design lessons aligned with the active learning cycle. And we can go to the next slide. Great. So I chose this technique because I had a problem. I had a physics lab exercise and people made their measurements and they got about halfway through, and then I asked them to measure something off of a graph. And in this particular lab exercise, it was something called a time constant, which is about how long it takes for the charge in a capacitor to dissipate once you let it discharge. And I was getting to this point in the lab and I was finding, people are getting really confused at this point. They don't seem to know the vocabulary and they don't seem to know how to read the graph. And so I asked myself, what can I do to fix this? And that's where trying to introduce a technique came in. So I was going around and I was seeing that the lab groups, a lot of them needed individual coaching, and this took up a lot of extra time in the lab. And if I could somehow fix this all at once at the beginning before the lab started, then that would be great. Initially, what I was doing with my lesson plan was I was giving a little vocabulary lecture to introduce the lab. And the vocabulary lecture talked about the graph they would see when they were doing their measurements, and it talked about some of the things that they could measure off of the graph. And I thought, well, let's try replacing the vocabulary lecture with an active learning exercise and see if anything improves with the confusion that I was seeing in students later on when they were trying the lab. And so the active learning cycle, hopefully it's going to target the confusion, and maybe the students will be able to do their labs more efficiently. And as a result, maybe I'll save some time and maybe I'll save the students some heartache. Next slide, please. So I tried this technique out in fall 2019 and again in spring 2020. In fall 2019, it was a face-to-face lab setting with the students in small groups. In spring 2020, there was the pandemic, and this portion of the course happened after the pandemic hit. So I wasn't able to do the lab portion in spring 2020, but I still did this active learning exercise. Next slide. Most of the people in my classes are trying to get into an engineering program at the University of Florida. But that said, they're coming in from all different levels. I get people all the way from high school dual enrollment students to mature learners who already have jobs with utility companies. I have a fairly broad cross-section of ethnicity. I got a lot of Hispanic people as well as white people and some Black people. So often I have a large amount of disparity in terms of how much preparation people have. Some people are fresh out of high school and they've taken a lot of math and physics recently. Some people have been in the workforce for a few years and they might have taken previous physics classes years ago and they're trying to remember what they learned from years ago. So I really have to try to make sure that I'm catering to all levels. So on the next slide here is how I implemented my active learning cycle. And this is a particular brand or flavor for a recipe on how you can develop an activity which is aligned with the active learning cycle. It's called process-oriented guided inquiry learning. It's often used in science courses to generate worksheets that you can use for small group settings. And they've slightly renamed some of the categories in the active learning cycle. They've got the exploration, they've renamed the introduce portion as concept invention, and then they've got application. So the starting point here is with the exploration, and you kind of think about what you want people to be able to do at the end. For me, it was that I wanted my students to be able to read the graph on the instrument and do that measurement of the time constant that they were having trouble with. And the idea behind POGL is that you start from what you want the learners to pick up at the end, and you sort of generate what they call a model. It's kind of like a worked example of what you want the students to be able to answer at the end. So often it has a pretty graphic, as simple as you can make it, labeled with some concepts and key vocabulary that the students need to know in order to answer these questions. And so this takes a lot of thought to generate a nice, simple model which is well labeled. What you do is you present that as the first part of the worksheet that you're going to give to small groups. And you ask a whole bunch of questions that force the students to look at all of the different aspects of the model that you've written out. And so they answer some questions about what they see on the model. The next stage in a POGL exercise is the concept invention. And students go and look at what they answered about the model, and then they try to summarize that. And often this takes the form of defining some of the vocabulary words that they looked at that were pointing at different aspects of the example. So then after they've defined all of the vocabulary and concepts that they saw in the worked example, then they move on to application. And that's where you ask them some of the questions that you're going to expect them to be able to respond to later on when you assess them in your course. Or in this case, things that I might ask them to measure during the lab exercise. So they get to practice this a little bit in advance. So this is my last slide here on what I learned from doing this with my students. And one of the things that was really surprising was that you can design these active learning activities, and they can take about the same amount of time during your class as it would take to develop a vocabulary lecture in your class. So you could take a 20-minute vocabulary lecture and you could turn it into a 20-minute POGL exercise, but you get a whole bunch of benefits from doing a POGL exercise instead of just doing a straight lecture. So one of the main things is that students experience a sense of discovery and a real ownership of the results instead of passively listening to your lecture. So one of the quotes I got from one of my students in fall 2019, she reached a point in my exercise where it turns out that there are two different ways to measure this thing that I wanted the students to be able to measure. And she did this second way in the POGL exercise, and I heard her say, now I see there are two ways to do this. And so it's really rewarding for students to discover for themselves how to do something without me just lecturing at them and they passively see it. So hopefully that agency, the sense of ownership, it leads them to retain the concepts better when they actually have to apply them in practice. And that actually worked in my lab. So what I found was that since students had been primed in advance with this extra sense of discovery, they were able to approach the graph in my lab, measure what they wanted to measure, and I didn't have to coach them as much when they got to that part of the lab. So it wound up saving me time, wound up saving me about a third of the lab, actually. The other things that you get from doing an active learning exercise, of course, is that you get the small group dynamics. So the students have to communicate with each other, they have to do a lot of teamwork, and so they hone these skills which are in demand in industry once they get out in the real world. And one of the important things when they're in small groups is that they have to be assigned roles. so that you don't have some students who get to just sit there not doing anything. And so this helps them to be accountable to each other for having learned some part, at least, of the material, if they all have a job to do. And that, again, helps them to have their own sense of discovery and to own the concepts that they're trying to learn. So I'm really glad that I tried this out. It seems like it really saved me and the students a lot of time, and I'm looking for other places in my course to try to adapt to using this technique. It's not useful for everything necessarily, but for sort of basic vocabulary and concept introduction, it seems to me like it's a really useful tool to replace conventional lecture.
Thank you, Brian. Very interesting. You know, I feel like that's such a good example of a faculty member observing a problem, thinking about the intervention, applying the intervention, and then measuring its results. So I think that I applaud you for taking that approach to tweaking your class and tweaking this lesson. We have a question about the active learning cycle. Could you maybe step back and give a review of the active learning cycle?
Yeah, so actually, Steve, if you just back up a couple of slides, we can put that picture back up. So you've got the exploration there. And so you start off by looking at an example of the world and how the world is working. You don't try to tell the students in advance how the world works. You try to let them discover it for themselves. And then after they have a look at how the world works, then you try to get them to summarize what they've observed and sort of refine down what they've observed. And then after that, you hope that they can take what they've learned about the world and apply that to some problems. And hopefully what you've done is designed this so that the observations that they're making about their world or about the topic are the ones that they're going to be looking at when they go to answer your questions on a test or an assessment.
Thank you. There is also a question about the use of the technique outside of a lab course. Have you used this technique outside of a lab course?
Yeah, so I teach an astronomy class, and I've started adapting some of the activities in the astronomy class that seem ripe for this sort of replacement of a vocabulary lecture with an active learning activity. And I think that it works really well even if you're not doing a lab. In particular, in my astronomy class, one of the things that I replaced with a POGIL type exercise was a part of my astronomy course where I'm trying to teach students that when they're looking at where to place a telescope, whether to build it on the ground at sea level or whether they should build a telescope in space, that one of the main goals is to think about where you can see different kinds of light. In space, you can see all different kinds of light, but the atmosphere blocks some kinds of light from getting to the ground. And it was a really easy exercise to adapt to POGIL because you can draw a picture showing the different kinds of light and how some of them don't reach the ground and some of them do reach the ground. You can ask some students questions about now which kinds of light reached the ground and which didn't, and then you can have them answer application questions about, okay, so now if you saw on that picture that ultraviolet light couldn't reach the ground, where should you put an ultraviolet telescope, in space or on the ground? So yeah, definitely it works even if you're just doing a lecture class rather than a lab class.
Okay, and I think we have one more question. Do you ever guide them with the questions you ask?
Yeah, so the questions that you ask during the exercise, um, they are pre-printed on the worksheet, so you don't have to worry too much about just saying them on the fly. But you definitely have to create questions which kind of build on each other. So you might start off with questions which ask about really obvious things in your worked example, and then you would progress to questions which ask about some more subtle aspects of the worked example. And then after that, it would be up to the student to start synthesizing that information into some definitions of the concepts that they saw.